Can data analysis beat the lottery? Hi everyone, my name is Armstrong Subero. I'm a computer engineer and scientist, and I was into AI way before it became all hype. So I spent weeks digging into player results from 1994 to 2025, trying to find hidden patterns. Here's exactly what I found and whether I would have made money or lost it. Disclaimer: I don't play Whe, I don't condone gambling in any way, and this video was done for educational purposes only. Play Whe is a popular daily lottery game played in Trinidad and Tobago based on a traditional Chinese numbers game. It's simple to play, but deeply cultural, and even seen by some as having spiritual significance. So what is Play Whe? Now, in Play Whe, you have 36 numbers, locally known as marks, and each one has a symbolic meaning. Players bet on one or more marks per draw. If your number is drawn, you win up to 26 times your stake. So here's how it works. There are 4 draws per day: morning, midday, afternoon, and evening. You can bet as little as $1, and if your number hits, you win $26 TT. You can also bet on multiple marks or a mark plus a promotional ball like a gold ball or a mega ball. So why is it so interesting and addictive? Well, many players have lucky numbers tied to dreams, events, or superstition. Numbers are based on ancient Chinese mark system. It's a blend of chance, belief, and community storytelling. So let's look at an example mark table. So the number 1 will be centipede, 10 will be monkey, 20 dog, 34 blind man, and 36 donkey. And people often say things like, I dreamed of a dog. That's the number 20, so they'll play it. So why does this make a great data experiment? Well, it runs 4 times a day, so there's tons of data. There's only 36 numbers, manageable for what we call hot-cold analysis. Many people believe in patterns, but is it just luck? Now, Play Whe is rigged, and I'll tell you why it's rigged against the players. The numbers are 26 to 1, so the odds are always in the house's favor. Even though Play Whe plays 26 times your bet, if you win, your true odds of winning are worse than 1 in 26. Here's the math. There are 36 numbers in Play Whe. Only 1 mark is drawn per game. So your chance of winning, your winning probability, is 1 in 36 or about 2.78%. So you have a 2.78 chance to win on a single bet. Now if you look at the payout, the game pays 26 times your bet, but fair odds based on probability would require 36 times payout to break even. So what we call a fair payout is the number of possible outcomes, which is 36 times your bet. Instead, you only get 26, meaning 10 times is skimmed off the fair payout amount. So here's what it means. Let's look at the aspect versus reality. For a true winning chance, 2.78%, that's 1 in 36. A fair payout with no house edge is 36 to 1. Actual payout is 26 to 1. You know, the edge the house has is like 28%. So the house is always statistically ahead. They pay less than the real risk you're taking. So let's do a quick analogy. Imagine if you and I flip a coin. But if you guess right, I only pay you 70 cents instead of $1. Over time, no matter how good you guess, I'll win. That's exactly how Play Whe and most gambling works. The odds are stacked against you. So the bottom line is, the payout is rigged lower than the true odds, which means even perfect strategy can't beat the house over time. Now what I did is, I produced something called a number distribution, and in fact, we could look at the number distribution over time for a random 6-month period. It appears to be fairly consistent, proving that the random number generation system works. However, as a computer scientist with subject matter expertise in hardware systems, I know most lotteries, including Play Whe, use random number generators to pick winners. But not all RNGs are perfect. Some systems use math-based randomness, natural randomness, and leaves tiny patterns. By studying thousands of past results, you might spot numbers that come up a little more often, because the hardware or software isn't as random as it seems. Hardware is made up of billions of transistors, which leads to inconsistencies on even the most expensive number generation systems. So all I would have to do is exploit these inconsistencies, and in theory, finding and exploiting those patterns could tilt the odds. even if just slightly, in our favor. I actually got this idea when my fiance started playing the game, and a few years ago while I was in UTT, I got the idea from a professor there to use my outstanding computer science skills to tackle the lottery system. So, I'll tell you the method I use in order to try to beat the Play Whe system, knowing we can exploit tiny inconsistencies in the number generation system. The first thing I had to do was to gather the numbers. Being a computer scientist, I tried to scrape all the little plus numbers from this Play Whe results website. I of course use Python with requests and a fast API backend. I also use Beautiful Soup to parse the HTML content, and the idea was that I could identify the HTML elements contained on the page, and this was the program I wrote to do it. This, however, failed because the website has restrictions in place to prevent that. So I tried using Microsoft Edge in debug mode, but that also failed. And I wrote the program using Selenium, but that also failed. So at this point, I was not even able to access the page regularly through the browser, so I had to use a proxy due to the website settings. I decided the best way to go about this was to use the proxy to gather the data manually and then try to analyze data that way. So I manually copied all data into spreadsheets, and I asked AI to analyze the mark frequencies from January 1995 to 2025. Based on the results of that analysis, I determined that during number 1995 to 2010, the random number generation used to generate the Play Whe numbers were the same. Based on what we've seen, from 1995 to 2010, they likely use a simpler random number generator because you saw more uniform distribution patterns. In recent years, especially during the 2020, new layers introduced, for example, when the Gold Ball, Mega Ball, Ultra Ball, and Mega Extreme Ball were introduced. These either changing number selection or they added probabilistic weighing on the data set. So using data before this year's will hurt the prediction accuracy unless you model to rule the shifts explicitly. So the amount of data needed. More data is needed for training, but only if it follows the same rules. So if we look at the time range, for the last 5 years, it has the most relevant consistent rules, but as a con, it has a smaller data set. If we look at the last 10 years, we'll get a balance between size and relevance, but it may include early stage of, rule change. If we look at the full data set from 1995 to now, which is a huge data set, it includes irrelevant but obsolete data. So my recommendation is, if you're building a predictive model for modern Play Whe numbers, start from 2015 onward, about 10 years ago. This will give us enough volume for pattern detection, and we also have the advantage of modern draw mechanics. We overlap when the mega promo balls begin appearing, then optionally, we could train a second model using only 2020 to 2025 data to see it performs better. Or training on both and give the recent more data weight using a decay function or time-based weighing. So as a bonus tip, we could look at temporal weighing. So we could use exponential decay weighing where results have more influence. This way, all our data helps, but it doesn't show out recent behavior. So, what it look like when I start looking at data and uses promo balls? Well, this were the results. So the first thing we did was determine the appearance of each promo ball. Then we divide data into eras. Then once we identify transition points, we train separate models per era and then build a hybrid ensemble model that uses the most efficient rules. We then add promo flags to our data set. So after the process, what I did is I scraped and gathered 3 years of data. And the tools I used Excel for data scraping, statistical analysis, and of course, simulated betting strategies, top 5, top 7, and top 10, in accordance with game theory principles. And, the strategy I use is to find hot numbers. So the testing strategies are betting on the top 5 numbers, betting on top 7, and betting on the top 10. And I simulated a $5, dollar bet per number. So losses when playing consistently without adapting, and how shifts in hot number over time causes losses. I also looked at comparing fixed strategies versus dynamic strategies. So what I learned is that it's not just about hot numbers. Lottery odds are designed to shift. Because I don't want to get into much trouble here, I won't tell you the shifting pattern. What I can say is every few months the window shifts, and I looked at a The model I trained was for put on the first portion of 2025 from January to June. And there was a time period when it was doing very accurate prediction, and then those predictions started to fall out as the window began to shift. So the thing about predictive decay is hot numbers get cold over time. So if you're gambling without adaptive strategies, it will almost always favor the house. So my final thoughts is beating the lottery long term is practically impossible, even with smart strategies. But learning about data, probability, and systems, that's a real win. Yes, it's possible to track these hot numbers over time, but I won't go into too much details here. I think I give a good layout. So, I have a good start. So anyone interested in following this process can, get an idea of the method to go about it. You can achieve very accurate results, but I really can't give too much here for obvious reasons. So, comment if you think I should, put up these spreadsheets and the hot numbers they came up with. And like and subscribe if you want more real world experiments. That's it, guys. Thanks for watching.